Today on How It's Made Dream Cars, a 21st century sports car with a famous lineage, the Jaguar F-Type. Based in the West Midlands, Jaguar began life as the Swallow Swift Company in Blackpool, England in 1922, producing sidecars for motorcycles. Then in 1927, the company moved into the car industry. The company decided that a new name was needed to reflect the power, speed and sleekness of their cars. And in 1935, visionary founder Sir William Lyons finally agreed, and the name Jaguar was born. Over the next 75 years, it would go on to produce some of history's most desirable and iconic sports cars. Produced in 1938, the SS Jaguar 100 was possibly the company's first real sports car. Launched in 1948, the XK120 was the first car with the legendary XK engine and had a top speed of 214 km per hour without the windscreen. Sir William Lyons' maxim of grace, space, pace was embodied in this 1965 Mark II, featuring the famous leaping cat on the bonnet. These cars are part of Jaguar's heritage, a company that went on to produce the legendary E-Type, which Enzo Ferrari once called the most beautiful car in the world. The all-new F-Type is a direct descendant, but while it reflects the company's past, it's a completely new design. The design for the F-Type took shape here, where all new Jaguars begin, at the Whitley Engineering Centre in Coventry, where a statue of company founder Sir William presides. It began with the simplest of tools, a pencil. A team of designers started sketching ideas, competing with each other to see who could come up with the winning design. Their assignment was to create a two-seater Jaguar sports car inspired by the company's history, but contemporary in every sense, meeting all modern safety and emission standards, but still echoing the Type history. Once there was a working design, the engineers gave their input and worked together with the designers to fine-tune the plans. Specialists then created a 3D digital model for the final design, and this was used to create a full-scale version of the car. After making a slightly smaller version of the design in expanded polystyrene foam, a 50mm thick layer of synthetic clay was applied, to which a crew of highly skilled modelers began making final adjustments. Working with the design and engineering departments, the modelers add and subtract clay to fine-tune the model. The work takes place in a climate-controlled environment, which maintains the required temperature and humidity to keep the clay from going too soft or hard. Unlike conventional clay, this material becomes more malleable when heated and hardens when cooled. A steel tool called a slick is used to remove minute quantities of clay according to instructions from the design team. The surface is then dampened and a slightly adhesive material is applied. The clay has a matte surface which absorbs light. This shiny material reflects light and once smoothed into place, mimics the effect of a finished coat of paint. This allows the designers to see how light will reflect off the surface. If the effect is not the one desired, the team continue to modify the clay to perfect the surface. While sketches and digital imaging are key elements of the design process, working with a full-scale clay model is crucial to reaching the finished design. Design elements that look good on paper or on small-scale models may not work when scaled up to full size. This is why it's so important to use clay that, unlike other materials, can be shaped, bulked up or removed at any point in the modeling process. Sculpting with painstaking attention to detail, the clay modelers are highly specialized and are in high demand within the automotive industry. Using a 3D measuring device, every change made is recorded on the digital version of the car. This information goes back to the design and engineering departments, where it's checked for feasibility. Changes wanted by the designers may not always meet engineering requirements, and vice versa. Eventually, the many teams working on the design reach a point called stop clay. This means they're finally satisfied with the full-scale clay model, and it's time to move to the next phase. The entire clay model is then scanned into special engineering software. This software can highlight the design to mimic how light falls on the car. The tool reveals any imperfections in the surface of the model. If any flaws are detected, the software is used to correct them. Other software is used to add paint to the model. Again, the surfaces are checked. Essentially, this software is a visualization tool that collates all the work by the various teams and fuses it into the final digital blueprint for the Jaguar F-Type. The design work complete, it's now time to start building the car. Jaguar uses nothing but aluminium for the body of the F-Type. It's lightweight, rust-proof and strong, but getting it to curve is a challenge. Even the chassis is made with aluminium. Because it's light as well as being strong, an all-aluminium car is much more fuel efficient than a car built from steel. Also, the aluminium components can be put together without welding them. First, a high-strength adhesive is applied to the surface of the components, which are then clamped in place. Specialized tools are then used to rivet the components together. Jaguar developed a new kind of rivet that, unlike conventional ones, sit flush with the surface of the part. This innovative method produces 87% less CO2 than welding. Aluminium is one of the most widely recycled materials in the world, which means that this factory can make more than half of the F-Type with recycled metal. By the time the car is finished, it will have 2,388 rivets, 563 fasteners, and 101 meters of adhesive. A team of robots then set to work joining the different sections of the chassis. They bring together the front bulkhead, the drive shaft tunnel, the passenger compartment, and the rear bulkhead. Once all the components are aligned and clamped in place, the robots equip themselves with the specialized riveting tools and begin joining everything together to form one solid, super stiff chassis. Amazingly, from start to finish, the process of building the chassis takes less than an hour. The rust-proof aluminium chassis will form part of the car's overall monocoque construction. In a monocoque construction, the external skin of the structure is designed to bear weight and stress. Instead of using a frame as a chassis that takes the entire weight of the car, the load of the car will be distributed throughout the structure. Once the robots have finished constructing the chassis, it travels on a track to the next phase of manufacture. Aluminium has a memory. This means it has a tendency to snap back into its original shape when stretched, and if stretched too far, it can crack. This is why forming the metal is tricky. These are huge stamp tool molds, called press tools. They're made of cast iron and weigh up to 50 metric tons each. Each will press flat sheets of aluminium, which are called blanks, into specific shapes. A stack of aluminium blanks head into an enormous stamping facility, where they'll be transformed into bonnets. At the beginning of the stamping facility is a hydraulic press, which exerts a force of 2,500 tons to form the aluminium. Technicians position the huge press tools in sequence along the line. Robots move the developing panel from one press to the next. The first stage is called the draw operation, which stretches the flat aluminium into the basic bonnet shape. The developing panel then proceeds to the next tool on the line. The second and third steps are called trim and pierce. One stamp tool trims off the excess metal, and the second tool stamps out openings called louvre holes. The bonnet now takes on its unique clamshell shape. This shape is one of the most distinctive design elements of the F-Type. The fourth and fifth steps in the line are called the flanging operations. Two different press tools fold over the sharp edges of the bonnet, creating a smooth perimeter around the rim of the entire object. This is the finishing touch. Because it's so hard to get aluminium to form into this particular clamshell shape, Jaguar uses a special alloy called A600. This alloy can be stretched beyond aluminium's usual limits. Once complete, each panel is inspected. When all the body panels have been pressed and trimmed into shape, an assembly team begins to fit them to the chassis. Using the adhesive and riveting technique we saw earlier, the body of the car is built. Car manufacturers have a name for an unpainted car body without its powertrain or wheels. They call it a body in white. Incredibly, because of the all-aluminium construction of the car, the F-Type's body in white weighs just 261 kilograms. All Jaguar cars go through the same paint process in the paint shop. Here, a different car model begins its 7.5 kilometer long trip through the massive facility, which is the size of 8 football pitches. The paint shop will coat the F-Type with nearly 14 litres of paint in total. Like all Jaguars, the F-Type goes through a series of stages in the painting process, including pre-treatment, an electro-coat, body sealing and sound deadening, a primer, and a base coat that gives the car its colour, and a final clear coat. The paint job is carefully examined on each car to ensure that it's flawless before it becomes a complete F-Type. Jaguars have always been known for their beauty, and the F-Type is no exception. It follows that tradition with its clean lines. But it's much more than just a stylish-looking car. Now that the body is complete, it's time to add the rest. To prevent damage to the paint and allow easy access to the car, the doors, bonnet and boot are removed. All the painted surfaces are then covered with protective panels. Each part is labelled with all the car's details. Next, the first stages of the car's trim are installed. These include soundproofing, door seals, electric window motors, and the mounts for the door mirrors, and some wiring. The bulk of the wiring waits under heaters that warm up the cables to make them more malleable and easier to install. These bundles of cables will relay the car's incredibly sophisticated electronics. Thanks to these systems, the F-Type can, for instance, shut down the engine as soon as the car comes to a complete stop. It can then restart the engine in less time than it takes for the driver's foot to move from the brake to the accelerator. This process can make the car as much as 5% more fuel efficient. The brake pedal, accelerator and fuse board are already in place as the heating, ventilation and air conditioning unit is installed. A specially designed hydraulic crane is used to lift the dashboard into place. This lessens the chances of damage being caused during installation. The dashboard comes pre-assembled for this specific car. Like all F-Types, this one has been made to order, and its future owner has chosen the colours and materials of the dash. The analog instrument panel is considered to be part of Jaguar's signature, but the company has also embraced the use of touchscreen technology. At this station, the engine is married with the front suspension and steering systems. The F-Type comes with either a supercharged V6 or V8 engine. The 5-litre V8 produces 488 brake horsepower at 6,500 revs, with a maximum torque of 625 Newton meters. This car can go from 0 to 100 kilometers per hour in just 4.3 seconds. A hydraulic lift raises the entire drivetrain, including the engine, transmission, steering unit, and the all-aluminium double wishbone front suspension, into position. It's then secured into place, and all the bolts are tightened to specific torque settings. Once the drivetrain has been installed, the suspension shock absorbers are attached to the top of the wheel well. Next, the car's convertible roof is installed. As with the dashboard, this roof was made to order for this particular car. While certain features of the roof may vary, all of them include insulation for soundproofing and improved climate control. Also, the F-Type's roof can fold up or down in just 12 seconds, even when the car is going 50 kilometers per hour. It's now time to reattach the boot lid. The company's engineers went to great lengths to distribute weight as evenly as possible throughout the car, so they placed both the battery and the windscreen washer liquid in the boot. This weight distribution results in a better handling car. Next, the doors are reinstalled. All the interior surfaces are covered with a protective plastic film to prevent any damage during assembly. The inside panel of the driver's door forms what the company calls the driver environment. The designers drew inspiration from an aeroplane cockpit, where all the controls are within easy reach and grouped according to their function. The car is now complete, but it's not ready to head out of the door yet. First, like each and every F-Type, it must pass stringent quality control tests. The car is driven onto a rolling road, and it's then put through its paces. Beyond the F-Type's design and engineering, the one big question is how it actually performs. These technicians are part of the dynamics team, who measure every aspect of the car's handling. Before beginning the test, the tyre pressure and wheel height are measured and recorded to make sure the results are consistent from each test drive. A laptop is plugged into a system of sensors, measuring equipment and data loggers that have been placed in various locations around the car. As the car is driven, these devices will record data such as the distance travelled by the wheels, the steering angle, the throttle positions, G-forces, yaw angles and brake pressure. Adjustments can be made in real time to some components, including the dampers, the differential and the power steering. For some dynamics tests, the F-Type is taken out on public roads, but here it's driven along tracks inside the highly secure Jaguar testing facility. The car is driven at varying speeds on a wide variety of surfaces, simulating as many different driving situations as possible. The rigidity of the car's structure is a crucial element in its performance. The stiffer the car, the more responsive it is to the driver. When designing the F-Type, Jaguar put a great deal of thought and work into making the car as rigid as possible. Additionally, the company chose to use all aluminium double wishbone suspension to achieve the highest performance while maintaining a lightweight structure. Jaguar also fine-tunes the sonic elements of all their cars in this specially designed area called a semi-anechoic chamber. An array of calibrated microphones are placed around where a driver and passenger's head would be. The mics are spaced according to the approximate distance between a pair of ears. There are 12 speakers in total distributed throughout the F-Type. The sound system is tested while driving, and based on the feedback, sound engineers fine-tune the calibration. For this calibration process, a specially designed test signal is used, which manages to be the equivalent of all popular music genres combined. Over 300 hours of audio calibration went into developing the F-Type sound system. It also adjusts the sound depending on whether the roof is either up or down. The sound system isn't the only element of the F-Type's sonic experience though. The sound made by the car has also been designed too. As air vents rise from the floor of the semi-anechoic chamber and blows cool air into the car, carefully positioned microphones listen to the exhaust pipes. Accelerating on the chamber's rolling road, the sounds made by the engine and exhaust are fine-tuned. The design of this car even takes into account the handles and mirrors, as the door handles sit flush to the surface until they're used. The roof also stows away invisibly when not in use, and is raised at the push of a button. The invisibility aspect of parts of the car are even incorporated in the interior, as the ventilation system appears when it's required. Continuing Jaguar's famous sports car legacy, the F-Type pays homage to its ancestry while employing state-of-the-art technology. Only time will tell if it will become one of the iconic cars of motoring history, similar to the D and E-Types. But the Jaguar F-Type is every bit a 21st century dream car.
Phantom Works want to become the biggest and best car restorers in America. It's a brand new Discovery series starting at 9 tonight. Next though, it's more how it's made, dream cars.